A microchip, also called a chip, a computer chip, an integrated circuit or IC, is a set of electronic circuits on a small flat piece of silicon. On the chip, transistors act as miniature electrical switches that can turn a current on or off. The pattern of tiny switches is created on the silicon wafer by adding and removing materials to form a multilayered latticework of interconnected shapes. Silicon is the material of choice in the chip industry. Unlike the metals normally used to conduct electrical currents, silicon is a semiconductor, meaning that its conductive properties can be increased by mixing it with other materials such as phosphorus or boron. This makes it possible to turn an electrical current on or off. The good news is that it's everywhere. Silicon is made from sand, and it is the second most abundant element on Earth after oxygen. Silicon wafers are made using a type of sand called silica sand, which is made of silicon dioxide. The sand is melted and cast in the form of a large cylinder called an ingot. This ingot is then sliced into thin wafers. Silicon is the material of choice in the chip industry. Unlike the metals normally used to conduct electrical currents, silicon is a semiconductor, meaning that its conductive properties can be increased by mixing it with other materials such as phosphorus or boron. This makes it possible to turn an electrical current on or off. The good news is that it's everywhere. Silicon is made from sand, and it is the second most abundant element on Earth after oxygen. Silicon wafers are made using a type of sand called silica sand, which is made of silicon dioxide. The sand is melted and cast in the form of a large cylinder called an ingot. This ingot is then sliced into thin wafers. There are two major ways to categorize microchips, by functionality and by type of integrated circuitry. In terms of circuitry, a chip can be analog, digital, or mixed. The difference between analog and digital function has to do with the electric signals they process. In digital chips, the signals are binary. In analog chips, the signals are continuous, meaning they can take on any value within a given range, and they use more traditional circuit elements, resistors, capacitors, and occasionally inductors. In terms of functionality, there are four main categories: logic chips, memory chips, application-specific integrated chips, ASICs, and system-on-a-chip devices, SoCs. The two most common types of chips, logic chips and memory chips, are digital. They manipulate and store bits and bytes using transistors. ASICs and SoCs are mainly a mix of analog and digital. Logic chips are the brains of electronic devices. They process information to complete a task. Among logic chips, CPUs, central processing units, are the original chips, first designed in the 1960s. But there are also processors with specific functionality in mind, such as GPUs, graphical processing units, which are optimized for visual display, and NPUs, neural processing units, designed for deep and machine learning applications. Memory chips store information. There are two types of memory, volatile and non-volatile. Volatile memory chips, such as DRAM, dynamic random access memory, are the working memory chips that save data only while the device's power is turned on. Non-volatile memory chips such as NAND flash save data even after the device is turned off. For example, DRAM helps to run programs on your device, whereas NAND stores your photos. Whereas DRAM is fast, NAND is slow to read and write data. ASICs are simple, single-purpose chips used for performing repetitive processing routines such as scanning a barcode. SoCs are essentially integrator chips. They are a relatively new type of chip that combines many chips and circuits in a single chip and may integrate things such as graphics, audio, camera, video and Wi-Fi. Chip improvements are behind the incredible increase in computing power and memory function that has allowed technology to advance to where it is today. 1956 to 2015, computing power increased 1 trillion-fold, thanks to chips. Think about this. The computer that navigated the Apollo missions to the moon was about twice as powerful as a Nintendo console. It had 32.768 bits of random access memory, RAM, and 589.824 bits of read-only memory, ROM. A modern smartphone has around 100,000 times as much processing power, with about 1,000,000 times more RAM and 7,000,000 times more ROM. Chip improvements are behind the incredible increase in computing power and memory function that has allowed technology to advance to where it is today. 1956 to 2015, computing power increased 1 trillion-fold, thanks to chips. Think about this, the computer that navigated the Apollo missions to the moon was about twice as powerful as a Nintendo console. It had 32.768 bits of random access memory, RAM, and 589.824 bits of read-only memory, ROM. A modern smartphone has around 100,000 times as much processing power, with about 1,000,000 times more RAM and 7,000,000 times more ROM. An integrated circuit or monolithic integrated circuit, also referred to as an IC, a chip, or a microchip, is a set of electronic circuits on one small flat piece, or chip, of semiconductor material, usually silicon. Large numbers of miniaturized transistors and other electronic components are integrated together on the chip. This results in circuits that are orders of magnitude smaller, faster, and less expensive than those constructed of discrete components, allowing a large transistor count. The IC's mass production capability, reliability, and building block approach to integrated circuit design have ensured the rapid adoption of standardized ICs in place of designs using discrete transistors. ICs are now used in virtually all electronic equipment and have revolutionized the world of electronics. Computers, mobile phones and other home appliances are now essential parts of the structure of modern societies, made possible by the small size and low cost of ICs such as modern computer processors and microcontrollers. Very large-scale integration was made practical by technological advancements in semiconductor device fabrication. Since their origins in the 1960s, the size, speed, and capacity of chips have progressed enormously, driven by technical advances that fit more and more transistors on chips of the same size. A modern chip may have many billions of transistors in an area the size of a human fingernail. These advances, roughly following Moore's law, make the computer chips of today possess millions of times the capacity and thousands of times the speed of the computer chips of the early 1970s. ICs have three main advantages over discrete circuits: size, cost, and performance. The size and cost is low because the chips, with all their components, are printed as a unit by photolithography rather than being constructed one transistor at a time. Furthermore, packaged ICs use much less material than discrete circuits. Performance is high because the IC's components switch quickly and consume comparatively little power because of their small size and proximity. The main disadvantage of ICs is the high initial cost of designing them and the enormous capital cost of factory construction. This high initial cost means ICs are only commercially viable when high production volumes are anticipated. An integrated circuit is defined as a circuit in which all or some of the circuit elements are inseparably associated and electrically interconnected so that it is considered to be indivisible for the purposes of construction and commerce. In strict usage, integrated circuit refers to the single-piece circuit construction originally known as a monolithic integrated circuit, built on a single piece of silicon. 2-3 In general usage, circuits not meeting this strict definition are sometimes referred to as ICs, which are constructed using many different technologies, e.g. 3D IC, 2.5D IC, MCM, thin film transistors, thick film technologies, or hybrid integrated circuits. The first customer for the new invention was the U.S. Air Force. Kilby won the 2000 Nobel Prize in Physics for his part in the invention of the integrated circuit. NASA's Apollo program was the largest single consumer of integrated circuits between 1961 and 1965. Transistor logic, TTL, was developed by James L. Buie in the early 1960s at TRW Inc. TTL became the dominant integrated circuit technology during the 1970s to early 1980s. Dozens of TTL integrated circuits were a standard method of construction for the processors of many computers and mainframe computers. Computers such as IBM 360 mainframes, PDP-11 mini-computers, and the desktop Datapoint 2200 were built from bipolar integrated circuits, either TTL or the even faster emitter-coupled logic, ECL. Modern semiconductor chips have billions of components, and are far too complex to be designed by hand. Software tools to help the designer are essential. Electronic design automation, EDA, also referred to as electronic computer-aided design, ECAD, is a category of software tools for designing electronic systems, including integrated circuits. The tools work together in a design flow that engineers use to design, verify, and analyze entire semiconductor chips. Some of the latest EDA tools use artificial intelligence, AI, to help engineers save time and improve chip performance. Integrated circuits can be broadly classified into analog, digital and mixed signal, consisting of analog and digital signaling on the same IC. Digital integrated circuits can contain billions of logic gates, flip-flops, multiplexers, and other circuits in a few square millimeters. The small size of these circuits allows high speed, low power dissipation, and reduced manufacturing cost compared with board-level integration. These digital ICs, typically microprocessors, DSPs, and microcontrollers, use Boolean algebra to process 1 and 0 signals. Among the most advanced integrated circuits are the microprocessors or cores, used in personal computers, cell phones, microwave ovens, etc. Several cores may be integrated together in a single IC or chip. Digital memory chips and application-specific integrated circuits, ASICs, are examples of other families of integrated circuits. In the 1980s, programmable logic devices were developed. These devices contain circuits whose logical function and connectivity can be programmed by the user, rather than being fixed by the integrated circuit manufacturer. This allows a chip to be programmed to do various LSI-type functions such as logic gates, adders, and registers. Programmability comes in various forms: devices that can be programmed only once, devices that can be erased and then reprogrammed using UV light, devices that can be reprogrammed using flash memory, and field programmable gate arrays, FPGAs, which can be programmed at any time, including during operation. Current FPGAs can, as of 2016, implement the equivalent of millions of gates and operate at frequencies up to 1 GHz. Analog ICs, such as sensors, power management circuits, and operational amplifiers, op-amps, process continuous signals, and perform analog functions such as amplification, active filtering, demodulation, and mixing. ICs can combine analog and digital circuits on a chip to create functions such as analog-to-digital converters and digital-to-analog converters. Such mixed-signal circuits offer smaller size and lower cost, but must account for signal interference. Prior to the late 1990s, radios could not be fabricated in the same low-cost CMOS processes as microprocessors. But since 1998, radio chips have been developed using RF CMOS processes. Examples include Intel's DECT cordless phone, or 802.11, Wi-Fi, chips created by Atheros and other companies. Modern electronic component distributors often further subcategorize integrated circuits. Digital ICs are categorized as logic ICs, such as microprocessors and microcontrollers, memory chips, such as MOS memory and floating gate memory, interface ICs, level shifters, serializer/deserializer, etc., power management ICs, and programmable devices. Analog ICs are categorized as linear integrated circuits and RF circuits, radio frequency circuits. Mixed signal integrated circuits are categorized as data acquisition ICs, including A/D converters, D/A converters, digital potentiometers, clock/timing ICs, switched capacitor, SC, circuits, and RF-CMOS circuits. Three-dimensional integrated circuits, 3D ICS, are categorized into through-silicon via, TSV, ICS and CU-CU connection ICS. The semiconductors of the periodic table of the chemical elements were identified as the most likely materials for a solid-state vacuum tube. Starting with copper oxide, proceeding to germanium, then silicon, the materials were systematically studied in the 1940s and 1950s. Today, monocrystalline silicon is the main substrate used for ICS, although some 3V compounds of the periodic table such as gallium arsenide are used for specialized applications like LEDs, lasers, solar cells, and the highest speed integrated circuits. It took decades to perfect methods of creating crystals with minimal defects in semiconducting materials' crystal structure. To allow identification during production, most silicon chips will have a serial number in one corner. It is also common to add the manufacturer's logo. Ever since ICS were created, some chip designers have used the silicon surface area for surreptitious, non-functional images or words. These are sometimes referred to as chip art, silicon graffiti, or silicon doodling. Thank you for watching.